Day 11. Let's implement stock price prediction using historical data with linear regression. We will use past stock prices to predict the future price of a stock. This project will involve using a data set that contains dates and closing prices, and we'll use linear regression to predict the future stock prices. So let's get started. So I'm going to go ahead and create a new Python file. This time I'll call it day11.py. So first, let's import the necessary libraries. First one, pandas. Pandas is used for data manipulation and handling time series data. Next, let's import from sklearn.model selection, import train test split. This is splits the data set into training and testing sets. Next, from sklearn.linear model, import linear regression, and this implement linear regression model for predicting stock prices. Next, from sklearn dot metrics, we will import mean square error and R2 score, and these are used to evaluate the performance of the model. Finally, I will import matplotlib dot pyplot as plt. This is used for plotting the actual predicted stock prices. Now let's start with the sample historical. I'll type it here. Sample historical stock price data. You can replace this with actual stock prices. You can use stock prices from Yahoo Finance API or Alpha Vantage. There are a bunch of different options available to add data here, but I am going to use some random data. So I'm going to say this is I create a date set. I'm going to call pd dot date underscore range. So there's this function available where you can provide a start date. I am going to provide a start date of start of this year 2024 dash 01 dash 01, and I'll say periods of 10 days, 10 consecutive days. Frequency is day, so I'll say d. So what this does is it generates a date range for 10 consecutive days starting from January 1st 2024. Next thing, I'll say a set of close. So this is the closing price of a particular stock. So I am gonna say, let's say 150, 152 on next day, 153 on the next day, 155 on next day, 154. It went down 156. I'm just giving some random numbers. 157, 158, and the ninth one and the 10th one goes up. So let's make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 days, 10 prices, perfect. Next thing I want to do is I create a data frame, pd dot data frame, and pass it the data. So this will convert the data set into a data frame. So I have that. Okay, let's make sure my Next, let's convert that date column to a numerical format or ordinal for regression analysis. So we have to use something like pd dot timestamp dot to ordinal, which converts the dates into ordinal format, which is numeric, which represents the number of days since a fixed point in history. This transformation is needed because the linear regression model works with numerical input. So this I will say df of date equal to df of date dot map to this. So this will take care of that. So everything is converted into cordial format, into an ordinal format. So next thing that I want to do is I want to display the first few rows of the data set. I can just say print So if you're using some API or something, this might be very important to display it just to check if everything is fine. Print df dot head. Okay, perfect. So that's good. Next thing that I want to do is I want to create my features and target variables. So I'm going to say x equal to df of I need date. That is my features, and then I need my uh, target, which is the closing price. I will say y equal to, you can add some more variables for features if you want, but I'm just using date, and then I'll use closing price as the target. Now next last step is just let's split the data set into training and testing sets. We can do that using train test split. Give it features, give it target, test size equal to 0.2, so that's 80/20 split, and then random state equal to 42, the seed same as before. X underscore train comma x underscore test comma y underscore train comma y underscore test. So that's what we'll get. This is our split the data set into training and testing sets. Perfect. So now once that is done, next step, let me move it all the way to the top. Next step is to train the linear regression model. So I'll say model equal to linear. So I'll initialize the model, and then I'll say model dot fit and pass it our x underscore train and y underscore train it to it. So it trains the linear regression model. Once the linear regression model is trained, let's do some predictions. So I'm going to say y underscore pred equal to model dot predict and pass it our test data set x underscore test. Now let's evaluate the model. MSE equal to mean square error, and inside this I will pass y underscore test and y underscore pred. Same thing for R2. I will give R2 underscore score, and I'll give the same values as here. Perfect. Now let's print them and check it out how good they are. F is, let's say, next line, mean squared error is MSE. Same thing for my R2 score, it's R2. Perfect. So that will print them out. Now finally let's plot the actual versus predicted stock prices. So for that I'll use the matplotlib plt dot figure. I am going to give a fixed size of 10,6, same as the last one that we did, and I'll say plt dot plot, and this time I'll give the x test data, y test data. We'll give a label to this. I'll call it actual stock prices, and I'll give a marker of oh, perfect. I'll do the same thing for our x underscore uh, test comma y underscore pred comparison. Label equal to predicted, and marker I'll change it to x. Next thing, let's give a title to this, and title I will call it actual versus predicted stock prices, and then I'll give a label to the x label, and I'll call it date is what I'm uh, printing out there, and it's in the ordinal format, so I'm going to do that. And y plot dot y label is our stock price, and that is in dollar value. let's use dollar. Okay, perfect. And then I will say print, display a legend. That's all I need to do. And finally, show the plot. So this will show me the plot of actual versus predicted stock prices. Next, if I want to check the test the model with a new data set or a future date, let's say I can say future underscore date equal to, let's select a timestamp of a particular date. Let's say 2024. I want to know 01/11. So we give the date for 10 days already. So what happens in on my 11th date? What is the price of this particular stock? Next, I will say uh, let's create a data frame with the feature name date. So I am gonna say future date equal to pd dot data frame, and to this I'll give a date value and pass it the previous future date value to it. So that's good. Now finally predict the stock price for the future date. You can do that by saying predicted price equal to model dot predict, and I want to predict based on this future date that I have. I'm going to say print and f, I'll say predicted stock price for that particular date is, I can say dollar predicted price at the element 0.2 f, so it's two floating points after the decimal, and that's what I want to do. Perfect. So now next, let's run it and check if it works. Now open this and I'll say python day11.py, and there you go. That's our date, it's our stock price, and as you see, it is very close to each other, the graphs, based on the predicted and actual prices. And next I am going to look at the mean square error is 0.06, very close to 0, so that's good, and R2 very close to 1, so that's good too. And what about my predicted value for the 11th day? It's 161. So the last price was 160 and the next predicted price is 161.21. So I would strongly recommend you to buy this stock. I'm not a investment guru, but based on this prediction I can say that. But if you were able to do this, that's great. If not, let me know and I'll get back to you.